Hi, my name is Cody Barr.
My name is Lainey Finday, and this is Integrative Science for Teachers class.
We're talking about atmospheric temperature and how to measure it using high altitude ballooning.
We're going to be using a temperature sensor.
And I'll be discussing changes in temperature based on altitude through the four main layers of atmosphere. Okay, we're started.
Okay, we're going to be doing a high altitude balloon project, and we're going to be using a temperature sensor to test or to record temperature. This is our sensor. This part right here is the actual sensor part. This blue wire up here is going to be connected to our data collector module, and then the red wire is going to be connected to our 1.5 volt battery. There's different materials used in different sensors for different temperature ranges, I guess, and this one is the copper one, and the range goes from -200 Celsius to 350 degrees Celsius. Okay, this device, it detects changes in the resistance based on temperature. So as the temperature changes, it changes its resistance of the metals used. A simple conversion would be if you wanted to convert your Celsius readings into Fahrenheit, you would start with your degrees. Like, let's say we're at 25 degrees Celsius, and then you would times that by 1.8. And then you would add 32, and then it would get you your Fahrenheit. So let's do that. 25 times 1.8 equals 45 plus 32 equals 77 degrees Fahrenheit. So our sensor, we're going to be attaching this to our high altitude balloon, and it's going to be recording temperature as it gets higher in altitude. So, and we're going to be using the 1.5 battery because it's thin and lightweight, and it will be easier to go up with our balloon.
Okay, I'm going to be talking about atmospheric temperature based on altitude. And one thing I want to start with is how the temperature ranges are not really intuitive to what you would think. Because like as if when you go higher in the altitude, it does get colder. But it's not intuitively based out like you would think. It would keep getting colder. This is what you would assume would happen. As you rise in height, you would lower in temperature. That's not really what happens, and we're going to talk a little bit more about how this actually works and the reasons why it does what it does. Okay, we're going to be talking about the four main layers of the atmosphere, starting with troposphere. That's about 12 kilometers thick on average, and that basically goes from the Earth's surface up about 12 kilometers. And if you look in here, you can kind of see the temperature change through that range. As you go about the average Earth surface temperature, about 15-20 degrees Celsius, you drastically lower in temperature as you increase in altitude. This is because at the lower levels, heat from the Earth itself warms the atmosphere, and as the altitude increases, the number of air molecules per square inch, centimeter, what have you, the density of air molecules decreases, which decreases kinetic energy overall. Okay? And then as we move up to the stratosphere, the altitude increases to about 10 to 50 kilometers. That's what the stratosphere is. And in this area, the air temp actually does increase. If you look here, as it goes up, it reaches a high of about -60 degrees Celsius, and then it starts to increase. This increase is caused by the ozone layer itself. It absorbs UV radiation and traps heat in that region of space. Okay, and then on top of that, we go up to the mesosphere. This is about higher than our balloon will go, but it's important to know that up on this level, it actually increases in temperature quite drastically to actually above what Earth averages. And this is because the average kinetic energy decreases, but as you move into this mesosphere, the UV radiation traps it, and then there's a huge drop off as just density of air molecules, of molecules themselves are available, so the density drops, kinetic energy drops. And then we go up to the thermosphere, which does have a drastic increase, and this is because it's warmed by absorption of solar X-rays. Oxygen and nitrogen in the atmosphere kind of trap the X-ray radiation, increasing their vibration speeds, increasing the average temperature. So even though the density of kinetic energy goes down, each individual unit, each molecule is at a higher frequency, higher vibration rate, increasing its temperature. And it goes between 800 and 400 kilometers, and during high sun activity, the thermosphere is about 500 kilometers in depth, I guess, height. Okay, so after we attach the sensor to the balloon and inflate it and it rises up, the balloon's gonna go to about 90 to 110,000 feet, which is roughly 30 kilometers, like 25, 30 kilometers in height. And now that's gonna have a wide range of temperature changes as it rises and falls. And if you look right here, the temperature changes drastically change a lot as you rise to the atmosphere. And right here you can kind of see the high altitude balloon mark. It's between 20 and 30,000 feet, and that really depends on the balloon integrity. Like if it pops early, it's not gonna go as high. If it lasts longer, it's gonna go higher. But we're shooting for that 90 to 110,000 range, which is right around here. And if you go from over there, that is actually probably one of the coldest regions this balloon can reach. It's about negative 60 degrees Celsius. But it's only that for the very highest part. For the majority of this, we'll see a slow, steady decrease in temperature to about that 60 degree mark. And if it goes much higher than that 25, 26 kilometer range, we might actually start seeing an increase in temperature as it rises. And this is really just an average, and it really depends on altitude. So we might see colder temperatures because we're a higher latitude north. But until we really get out there and see the temperature of the day, we're not gonna be able to guess the range that temperatures we're gonna see during this experiment. Yeah, I'm Cody Barr.
I'm Lainey Finding.
And this was our discussion about high altitude ballooning and the atmospheric temperatures we're gonna kind of see during that.
I gave an overview of the temperature sensor we will be using.
And combined with those, we kind of have an idea of the range of temperatures we expect to see. And now it's just up to the experiment itself to see if we match our expectations. So that's going to be, we're going to wait for our launch to see that. And that was our high altitude ballooning video.
Thanks.
Thanks.